Hello everyone, welcome back to MargDarshan. Here we are going to see another 22 questions of SOM, which will boost up your preparation level for HPCL. Yes. See, here is the first question. Let's start now. Sorry, it's a miss. Okay, these are options given to us, and we have to. It was kind of match the following question. So they may give you the various possible answers A to 1, B to 2, something like that, and you have to choose accordingly. See, subjected to bending moment at the end of cantilever. Okay, beam it should be. So see, bending moment at the end of cantilever. M. Okay, so it should be giving us what they're asking. Okay, we will try option B. Cantilever carrying uniformly distributed load over the length. They're saying uniformly distributed load. Okay. So I think they are asking us for the BMD. If I'm not wrong, will be yes. Okay. So now see. For this case, the cantilever carrying uniform this wala case, this answer would be C. Yeah. So SFD would be linear and BMD would be parabolic for this case. So we have got B2 3. Okay. Cantilever carrying varying load, either this or this. So in this case, SFD would be parabolic, BMD will be cubic. So for C, we have got two. Okay. A beam having load at the center and support at the ends, like this. So SFD would be like this, and the BMD will be triangle. So D का 1, hence A का भी क्या आएगा 4, क्योंकि बेंडिंग मोमेंट कांस्टेंट है ना यहाँ पे ए फर्स्ट केस में फॉर ए. So the BMD would be something like this, rectangular piece. Okay. So we have got these answers. I hope you got the first question. Okay. So it was on the basic concept that we will learn. ठीक है. So अगर if we are moving from a loading diagram to SFD, add 1 to the degree of the curve. Okay. So it is now, if it is UDL, it will become linear like this. If it's linear, it will become parabola. If parabola, it will become a cubic graph. Okay. So we have to remember these things. Okay. So I hope this question is clear. Next, let's move to the second question. A freely supported beam at its end carries a, just a minute. I will shift myself here. Carries a central concentrated load and the maximum bending moment is M. Okay. If the same load is uniformly distributed over the beam length, what is the maximum bending moment? Okay. Now see, a supported beam means simply supported beam. Sorry for the diagram. Okay. Like this. Carries central load with a maximum bending moment M. So let's say this is W. The reactions will be W by 2 and W by 2. And this is L by 2 and this is L by 2. So maximum bending moment here in this case will be W by 2 into L by 2. WL by 4. Okay. And from here, if the same load is uniformly distributed, okay. If the same load is uniformly distributed, I will change color over here. This is W uniformly distributed, length L. Okay. So reactions will be mm, if the same load be uniformly distributed. Uniformly distributed, so here it should be coming L because it should be W by L. Okay. So this that because that's how it would be uniformly distributed over the length. So this will become reactions will become W by 2 again, and the moment here will be, if I'm not wrong, yes, W by 2 into L by 2 minus W by L. Okay, this is up till this into L by 2 into L by 4. So that should be giving me as WL upon 8 if I'm not wrong. L to L will cancel, yes. Right, yes. Hence, this is the M2. Therefore, M2 is equals to M by 2. Okay. So this was pretty straightforward. Just you have to understand the language. This is given like W by L. So that's how it will become uniformly distributed. एंड जस्ट मैंने यहाँ से भी हिंट ले लो कि अगर W लेते तो L स्क्वायर का टर्म आता है यहाँ पे और वी हैव नॉट कंपैरिजन फॉर दैट ओके सो वी हैव टू कीप दिस इन द सेम proportion of L as that of M okay so we have to do this at W by L and eventually we will get option B as our answer. Okay, now let's move to next question. Okay, this is a quite lengthy question. If you get this question in the examination, please keep it for the first round. Okay. A horizontal beam carrying uniformly distributed load as shown. For resultant bending moment at midspan shall be 0 if A by B is. You may just directly remember this formula also. Okay, we will just try it here. See, since it's W over here, W distributed load at the midspan, na. So, okay, so reactions will be R1 equals to R2 should be equals to W into yes 2A plus B by 2. Okay. एंड नाउ वी राइट मूवमेंट एट मिड स्पैन के लिए एम तो अगर हम लोग देखें तो W इंटू 2A plus B अपॉन 2 इंटू B/2 ठीक है माइनस W इंटू A plus B/2 हाँ इंटू A plus B/2 अपॉन 2 शुड बी इक्वल्स टू 0. ओके आई विल चेंज कलर ओवर हियर ठीक है if you go like this you will get A by B as 1/2. So I hope you got the procedure. We wrote the bending moment at the midspan at the center. And this should be 0. So we may write it like total जो uniformly distributed load के वजह से moment है equals to the जो reaction के वजह से आ रहा है. So this should balance it out together and we will get A by B at 1/2. Okay. So let's move further. A beam simply supported at equal distance from the ends. So this is a overhang beam. This carries equal loads at each end. P, suppose this is P. Which of the following is true? The bending moment is minimum at midspan. Okay, the bending moment is minimum at the support. Let us first draw the SFD here. So SFD shall be like this, P, and again here to P, move on further here, then P minus P. Okay. So now see, here between the two supports, since shear force is 0, and we know dm by dx is equals to V, right? Sorry, dm by dx equals to V. Just a minute, sorry. Yes, right. Hence, bending moment should be, and as you can see, 0 डिग्री कर्व है यहाँ पे, तो जो बेंडिंग मोमेंट लाइन बनेगा वो रेक्टेंगुलर बनेगा। वैल्यू तो ये मैक्सिमम हो गया एज पर दिस, तो ये तो 0 है, तो मैक्सिमम तो सभी पॉइंट पे सेम ही आएगा। लेकिन यहाँ पे जो बेंडिंग, सिंस हियर shear force diagram degree is 0, the bending moment should be a straight, sorry, horizontal line. Okay, so bending moment will be uniform, should be uniform. ठीक है ना? So as per we can see, the option D will be the correct answer over here. Okay, so bending moment is minimum at the midspan, no. Bending moment is minimum at the support, support पे तो high है, maximum है. The bending moment varies gradually between the supports, no. The bending moment is uniform between the supports, yes. So this is how this could be tackled out. Okay, this is a bit conceptual question, but I think after this you will be able to handle out. Okay, let's move further. Question 5. Which of the following statements is or are correct? In uniformly distributed load, okay, so as we can see over here, just a minute, give it a second to me. Yes, first option is in uniformly distributed load, the nature of shear force is linear and bending moment is parabolic. Just now we have seen uniformly distributed load, shear force must be linear. Yes, because degree would be added up by 1. Okay, so uniform to linear and linear to parabolic. Yes, so option number 1. Yes, so this option is, sorry, is this option totally correct? Yes. In uniformly varying load, the nature of force is linear and the bending moment is parabolic. No, this is absolutely wrong. As we have seen in the one, uniformly distributed load होगा तो ही linear आएगा shear force and bending moment parabolic. Since यहाँ पे varying load है, therefore SFD would be parabolic. Yes, parabolic, and BMD will be cubic. Okay. Under no loading condition, the nature of shear force is linear and bending moment is constant. Under no loading condition, shear force will be not linear, it should be constant. Or it should be either, I guess, 0, because this is a properly mention नहीं किया उन लोगों ने. नो लोडिंग कंडीशन है, मतलब सिर्फ उसका सेल्फ वेट भी हम लेंगे, तो ये ऑप्शन ही, आई थिंक दिस इज नॉट द प्रॉपर फ्रेम ऑप्शन. ओके, सो आई थिंक डी शुड बी द करेक्ट आंसर, क्योंकि नो लोड कंडीशन है, तो आई थिंक shear force will be like this and bending moment will be linear as far as my opinion is concerned. So I think option 1 should be the correct answer over here. Okay, yeah. Two beams of equal cross section are cross sectional area are subjected to equal bending moment. If one beam has square cross section and other has circular cross section, then which of them would be stronger? See, for stronger criteria, we have to check the section modulus. We have to check the section modulus Z. Okay. For the square, it is a cube by 12, for a cube by 6, and for this is pi d cube upon 32. Okay. So we have to come do the comparative analysis over here. So we'll move here right now like this. See, both have equal cross section. So a square is equals to pi by 4 d square. Therefore, a is equals to root pi by 4 times d. Now if we put in over here, now see, just put it over here. I'm doing it here. Okay. So root pi by 4 d का होल क्यूब अपॉन 6, एंड जो यहाँ पे आएगा पाई डी क्यूब अपॉन 32. तो पाई का क्यूब तो आएगा पाई रूट पाई, सो पाई डी क्यूब, तो यहाँ पे कॉमन लेंगे हम लोग, यहाँ से बात कर रहा हूँ मैं. ओके, फ्रॉम हियर पाई डी क्यूब तो कांस्टेंट लेंगे, तो रूट पाई यहाँ पे आ जाएगा, एंड देन रूट 4:2, 2 क्यूब इज 8, सो 48 आएगा, एंड दिस इज लाइक दिस, एंड दिस वुड बी पाई डी क्यूब अपॉन 32. थोड़ा मिस्टेक हो सकता है, लेकिन ये नेचुरली ज्यादा आएगा. Oh, sorry, sorry. Square is sorry. I am extremely sorry. A is root pi by 4, na? So this is root, just a minute. This is root pi by 2 times D. Okay, so A cube by 6. So just a minute. If we check for the circle square के लिए A cube by 6, तो root pi by 2, this is A, D whole cube. And Z circle का आएगा pi D cube upon 32. You can generally see it's greater. Square के लिए ज्यादा आएगा, hence square is the more stronger beam. C is the correct answer. Just देखिए यहाँ पे रूट पाई तो आएगा पाई इंटू रूट पाई अपॉन 8 इंटू डी क्यूब. This is generally obviously greater than the pi d cube by 32. Hence option C will be the correct over here. Right? Next, let's move forward. In a cantilever subjected to a concentrated load at free end. Okay. This is a cantilever. To a concentrated load at free end. Say W. The bending stress is maximum at free end. No, because the shear bending moment will be the critical section is always at the not at the fixed end. Okay, so this is incorrect. The maximum shear stress is constant along the length of the beam. Yes, because SFD if we draw, this should be W to W. So this is constant. And for maximum shear stress पूछा है, तो depending on the cross section of the beam, that should vary, but the वो उसके अकॉर्डिंग आ जाएगा. लेकिन shear, because shear stress shear force is common ना, so shear stress would be same. This is correct. The slope of the elastic curve is 0 at the free end. Yes, correct. हम लोग जो लिखते हैं कि dy by dx जो स्लोप आता है इसका यहाँ पे, दिस इज 0, वही एंगल होता है हमारा. Is correct. So B is the correct answer. 2 and 3 are correct. One is incorrect. Okay. So these kind of questions are more frequent in HPCL RCFL examinations because they have to check your more concepts in minimum amount of given time. Okay. So they will ask you this kind of question also. So be ready for this. Now question number 8. In the case of beams with circular cross section, What is the ratio of maximum shear stress to average shear stress? Okay. Now see. I will change pen color. Oh, that's a good circle. If we take any section over here at Y and the radius is R. Okay. So the shear stress shear stress as at any section, sorry, given as V upon 3I into R square minus Y square. Okay. Now if we simplify it further, it should be V is so shear force 3 into I is pi by 64 D क्यूब आया D पावर 4 आएगा ना तो 64 इंटू D को हम लोग लिखते 2R पावर 4 इंटू R स्क्वायर माइनस Y स्क्वायर ठीक है दिस शुड बी V अपॉन 3 पाई 2 पावर 4 इज 16 अपॉन 4 इंटू R पावर 4 इंटू R स्क्वायर माइनस Y स्क्वायर ठीक है सॉरी 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 so this should be 4 upon 3 V upon pi. We will just keep R square over here and we will move R square inside. So this should be 1 minus Y square upon R square. So this is tau maximum. Sorry, sorry. This is tau at any section. Now we will put, we know this should be maximum at the new, not the new, yes, for circular section exactly. Mm, yes, this should be maximum at the central and axis. The neutral axis is same here. So now tau maximum would be 4 upon 3 V upon pi r square. And tau average would be V upon pi r square. If we take the ratio, 4 by 3 is the correct option from here. Okay, this was a pretty straightforward. You just need to arrange them again so you will get the final answer quickly. So let's go now ahead. A T section is simply supported and subjected to a uniformly distributed load over its whole span. The maximum longitudinal stress in the beam is occurs at, sorry. See, longitudinal stress is asking, so it is the bending stress, not the shear stress, okay? Because if we consider a beam like this, and if we take a section and it is ulta T या सीधा T बोला है, तो वो ऐसे रहेगा longitudinal है ना तो यहाँ पे तो आएगा बेंडिंग स्ट्रेसेस ओके सो दिस इज न्यूट्रल एक्सिस देखो T के लिए न्यूट्रल एक्सिस समवेयर अराउंड हियर तो मैक्सिमम डिस्टेंस तो बॉटम फाइबर का है यहाँ से एंड एज पर अवर फ्लेक्चर फॉर्मूला सिग्मा इज इक्वल्स टू एम वाई बाय आई सिग्मा इज प्रोपोर्शनल टू वाई तो वाई जिधर से ज्यादा उस at that section at that plane the bending stresses will be higher so bottom fiber of the web ठीक है this was easy but you have to understand the language of the question okay let's move ahead 10th question consider the following statements a cross section of a member of a truss experiences uniform stress mm, yes because stress का main criteria होता है कि no lateral loading will be acting only longitudinal and axial loading longitudinal means axial loading so एक मतलब एक समझो ट्रस्ट का मेंबर है तो वी कंसिडर ना कि यहाँ पे पी है तो यहाँ पे भी पी ही आएगा अगर इनकेस बाय चांस समझो ये हमें दिया है कि यहाँ पे भी लोड लग रहा है यहाँ पे भी है या यहाँ पे भी है तो दिस इज द मेंबर ऑफ फ्रेम नॉट द ट्रस्ट दिस इज द ट्रस्ट मेंबर ओके सो yes this is correct option cross section of a beam experiences minimum stress no see minimum in the sense it's asking us like see I will just explain you over here if we consider rectangular or square cross section. This is like this ना variation. Oh, I'm sorry. क्या बना दिया यार. अगर ये टेंशन में है तो ये कंप्रेशन में आएगा. तो मिनिमम तो नहीं है लेकिन वेरी कर रहा है. मैक्सिमम भी है एंड मिनिमम भी है. सो दिस इज इनकरेक्ट. क्रॉस सेक्शन ऑफ अ बी एक्सपीरियंस लीनियरली वेरिंग स्ट्रेस. ये जो अभी हम लोगों ने दिखा यहाँ पे. एब्सोल्युटली करेक्ट. क्रॉस सेक्शंस ऑफ अ ट्रस मेंबर एक्सपीरियंस ओनली कंप्रेसिव. नो. टेंशन भी आ सकता है कंप्रेसिव भी आ सकता है. दोनों पॉसिबल है. दिस इज इनकरेक्ट. सो करेक्ट कौन से हो गए 1 and 3. ओके सो आंसर फॉर दिस क्वेश्चन इज 1 and 3. ओ इट इज अ गुड क्वेश्चन because you have to understand it properly and then before answering. So this is a good question. Okay. देख नहीं रहा हूँ ना थोड़ा. Yes. Okay. So, in the design of beams for a given strength, consider that the conditions of economy of the use of the material would avail as follows. Will avail as follows. Sorry. A rectangular cross section is more economical than the square section of the same cross sectional area. Mm, yes, we can say because same cross section area है ना. Right. Correct. So I think option A. Yes, one is correct. And I will give you one more theoretical aspect over here कि जो section model से हम लोग prove करते हैं कि always remember one this. Always remember this कि Z, sorry, Z of I is greater than Z of rectangular is greater than Z of square is greater than Z of circle. ठीक है ये थोड़ा याद रखना हमेशा. You should be remembering this because see now rectangular is more economical, yes, and more strong for the given cross same area. Okay, circular section is more economical than square. No, I section is more economical. This is the most economical. So 1 and 3 are the correct options. Okay, just remember these points for the same volume for same material. Right. Question number 12. A hollow shaft of the same cross section area and material as that of the solid shaft transmits. ठीक है इसके लिए एक थोड़ा लेंदी डेरिवेशन भी है कि कि टॉर्क इज जनरली प्रोपोर्शनल टू द पोलर सेक्शन मॉडुलस और जस्ट से जे बिकॉज मटेरियल तो सेम इफ वी राइट द टॉर्क टी बाय जे इज इक्वल्स टू जी थीटा ओवर एल. ओके जी कांस्टेंट है मटेरियल से में तो मेरे ख्याल से आई थिंक ये भी सेम ही आना चाहिए. थीटा वी में कंसिडर इट एज अ कांस्टेंट ओवर हियर. तो अगर हम लोग देखें तो इट शुड बी टी इज इक्वल्स टू लेंथ भी सेम है ना. टू जे अगर जे हम लोग देखें जे हॉलो सो दैट शुड बी जस्ट अ मिनट. आई थिंक आई एम मेकिंग सम मिस्टेक ओवर हियर. Yes, so this is the torque and this is JH we will consider for the comparison is sorry I was wrong here just a minute. Always when you consider this is the polar section modulus and polar movement and polar section modulus थोड़ा सा difference है कि polar section modulus. Okay, so T1/T2. T1 अगर हम लोग हॉलो ले ले तो π/32. ठीक है D1 पावर 4 माइनस D2 पावर 4 ये जो सेक्शन मॉडुलस है वो आएगा मैक्सिमम d1/2 इफ आई एम नॉट रॉन्ग। क्या आएगा इसके लिए, इस d1/2 ना, राइट। एंड उसके लिए क्या आएगा, t2 आएगा। t2 आई एम डायरेक्टली राइटिंग इट एज ds/2, जो सॉलिड शाफ्ट है उसके लिए, अपॉन π/32 ds³ राइट। यस, एंड एरिया सेम है ना क्रॉस सेक्शनल, तो वी कैन राइट इट एज π/4 d1² minus d2² should be equals to π/4 ds². Therefore, we can write d1² minus d2² is equals to ds². Okay. Now, if we see t1 upon t2 is equals to 32, π/32 तो कैंसिल हो जाएगा, 2 कैंसिल हो जाएगा। ठीक है, सॉरी ds⁴ है यहाँ पे, आई एम सॉरी। ओके, सो d1⁴ माइनस d2⁴ को वी कैन राइट a² माइनस b², तो a² आएगा d1² प्लस d2², और वो जो आएगा d1² माइनस d2², ओके, इंटू ds, फाइन, अपॉन d1 इंटू ds⁴। सो अगर यहाँ से कैंसिल हो जाएगा तो ds³ बचेगा नीचे। हम्म, ठीक है, देखिए। सो d1² प्लस d2² अपॉन d1, नीचे आएगा ds³, ds नहीं, वो d सफिक्स, सॉरी, और दिस इज ds²। फिर सो क्या बनेगा कि ds² आएगा तो ऊपर से ds कटना चाहिए। हाँ बराबर, राइट। सो दिस शुड बी d1² प्लस d2² अपॉन d1 इंटू 1 अपॉन ds सॉलिड। तो अगर हम लोग इसको देखें तो आएगा d1/ds इंटू, हाँ, लेकिन सेम एरिया के लिए रिमेंबर वन थिंग कि d1 इज ऑलवेज ग्रेटर देन ds, अगर वी आर कंसिडरिंग द कंपेयरिंग द सॉलिड शाफ्ट टू द hollow shaft, yes. So अगर d1 greater than ds है तो this expression is always greater than 1. Hence it will be transmitting the more torque. This was quite challenging to understand, but just remember this polar section modulus and this wala term. So we'll get it easily. So, okay. So let's move ahead. Question 13. For a power transmission shaft transmitting power P at n RPM, its diameter is proportional to. Okay. Now see. The maximum torque is pi d cube upon 16. Okay. Into tau. Hmm. And the power can be written as 2 tau, and power can be written as, correct or not? Yes. And torque की जगह पे we can write it as, hmm, hmm, so 2 pi n upon 60 into t की जगह पे π/d³ अपॉन 16 into tau। अगर सी एस स्ट्रेस हम लोग कांस्टेंट मान ले, ठीक है, सो देयरफॉर d विल बी p/n 1/3। तो हम डायरेक्टली वी में ऑब्जर्व इट लाइक दिस। ओके, so we had to do nothing in this as much, just we have to write the maximum torque that can be applied over there, and from there you have to write the power equation, and from there you can just follow as it is p/n whole cube, considering that shear stress induced will be constant over there. Okay, so we shall move to the next question now. Question number 14. Maximum shear stress induced in a power transmitting shaft is डायरेक्टली प्रोपोर्शनल टू द टॉर्क ट्रांसमिटेड। अभी हम लोगों ने देखा ना कि मैक्सिमम shear स्ट्रेस डायरेक्टली प्रोपोर्शनल टॉर्क ट्रांसमिटेड, यस है। ऑप्शन वन इज करेक्ट। इनवर्सली प्रोपोर्शनल टू द क्यूब ऑफ डायमीटर, यस ये भी करेक्ट है, 16 टी अपॉन पाई डी क्यूब आएगा टाउ मैक्स। ठीक है। एंड डायरेक्टली प्रोपोर्शनल टू पोलर मोमेंट ऑफ इनर्शिया, नो, वी could just recall the torsional inversely है, तो this is incorrect, so 1 and 2 are correct, option D is correct. This was easy, okay. 15. So power transmitting solid shaft of diameter D, length L and rigidity modulus L G, sorry, is subjected to a pure torque. Al maximum allowable shear stress is tau. The maximum strain energy per unit volume in the shaft is C. We can write it as maximum strain energy U is equals to 1 by 2 tau xy into gamma xy. This is a standard formula. And for the gamma, we may write it as tau xy into tau xy upon G. So this should be given as tau square upon 2G, U maximum. And we were to find out the U min average. That should be tau square upon 4G. Okay. Just remember these two. Remember this one fundamental equation. U is equals to half tau xy gamma xy. Rest is simple. Okay. So we have done with 15th. Now, what is the total angle of twist for the stepped shafts subjected to the torque T? Now, always remember since this is a series, so the total theta will be equals to theta 1 plus theta 2. Theta 1 के लिए we will write torque तो same आएगा T into 2L upon G1 into J1 plus torque तो same आएगा into L upon G2 into J2. जस्ट डू इट, कैलकुलेशन मैं आपके ऊपर छोड़ रहा हूँ क्योंकि कैलकुलेशन अभी बहुत इजी है यहाँ से। J1 की जगह पे पाई बाय 32 इंटू डी टू द पावर 4 एंड उसके जगह पे पाई बाय 32 इंटू 2d पावर 4, बस। बाकी रेस्ट इज ऑल सिंपल, ओके। एंड द ऑप्शन आंसर विल गेट ऑप्शन डी एज द करेक्ट आंसर। लेट्स मूव अहेड। The diameter of a solid shaft made of steel rotating at 250 rpm is 45 mm. The shaft is designed to transmit the 50 kilowatts. What will be the factor of safety if the ultimate shear stress at yield is this much? Okay. RPM we know, power we know. Now see, I will give one working algorithm here, okay? First find that maximum torque. Maximum. Okay. Then from this, we'll find the tau max. Maximum shear stress. Okay. And since factor of safety is equals to tau ultimate upon tau maximum. Okay. So for this case, you will get the answer as, just a minute, I will have to check over here. You will get it as 4, option C. Okay. So this is the pretty straightforward question, but this is good. Some calculations are involved in this. Solid shaft of diameter 100 mm and length 1000 mm is subjected to a twisting moment T. The maximum shear stress developed in the shaft is 60 MPa. Okay. A hole of diameter 50 mm diameter is now drilled throughout the length of the shaft. To develop a maximum stress of 60 MPa in the hollow shaft, the torque must be reduced by. This is a good conceptual question. Actually, this is a gate level question. If you get this kind of question, just leave it in the first go. Okay. Otherwise, it is going to kill your time unnecessarily. So I will suggest to skip this. Now, how we can write it as like this? Just a minute. Sorry. So you can write it as like this. See. Now the torque will be given as T. Okay. T1 we will consider for the solid wala case. Should be equals to tau into J upon R. Okay. Now see what they have said that D naught outer diameter is same. In solid. Okay. So R will be same. Tau is maximum is 60 here, and actual which is working is also 60. So tau is same. Therefore, T1 upon T2 should be equals to J1 upon J2. Okay, so T2 hollow के लिए था, तो we will just shift it over here. T2 upon T1 should be equals to J2 कितना आएगा, तो पाई बाय, तो वो तो टर्म कांस्टेंट हो जाएगा, मतलब कैंसिल हो जाएगा, सॉरी। तो अगर J की हम लोग बात करें तो कितना आएगा कि 150 था ना आउटर डायमीटर 100 mm में, तो 100 पावर 4, ठीक है, माइनस 50 का इनर डायमीटर, तो 50 पावर 4 अपॉन 100 पावर 4। यस 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 यस। अगर ठीक से देखेंगे तो ये आएगा मेरे ख्याल से 100, अगर हम लोग कॉमन ले लें नीचे से, फ्रॉम द न्यूमरेटर एंड डिनोमिनेटर वी टेक 100 पावर 4 कांस्टेंट, तो इट विल बी कैंसिलिंग आउट 1 माइनस 50 पावर 4 अपॉन 2 पावर 4 इंटू 50 पावर 4। करेक्ट ना? 50/60, if I'm not wrong. Yes, yes, right, correct. This is 15 upon 16. Therefore, T2 is equals to 15 upon 16 T. Now the question actually asked this, अगर ये ऑप्शन में होता 15/16, so it's definitely that we will in hurry will mark the 15/16 T. But it's reduced by, okay, so reduced by के लिए कितना आएगा, T minus 15 upon 15 T upon 16, which is T/16. Okay, so option will be D over here. This was a good question. It's a little bit of concept involved, and a chance of a silly mistake is prone to be here. Okay, you will commit the silly mistake if options are framed so such that. Okay, so this was all about the question 18. Okay, 19. While transmitting the same power by shaft, if its speed is doubled, what should be its new diameter if the maximum shear stress induced in the shaft remains the same? Okay. Okay. Maximum shear stress is same. Therefore, T1 upon D1 cube, T2 upon D2 cube. ठीक है. T1 को we can write it as, see, T1 P1 is equals P is equals to 2 pi NT upon 60, right? So T को हम लोग लिख सकते हैं P upon N into some constant K. तो कांस्टेंट तो कट ही जाएगा, सो P अपॉन N इंटू D1 क्यूब शुड बी इक्वल्स टू, सेम पावर बोला है तो पावर भी कैंसिलिंग आउट, P अपॉन N इंटू 1 D2 क्यूब, so N1 इंटू P कैंसिलिंग आउट, देयरफॉर N2 अपॉन N1 D1 क्यूब अपॉन D2 क्यूब, ठीक है, तो N2 शुड बी इक्वल्स टू D1, स्पीड इज डबल किया ना, सो 2 टाइम्स N1 फॉर D1 cube should be equals to 2 times D2 cube. D2 is equals to D1 upon 2 power 1 by 3. So option D is correct over here. Okay. So I hope you got this, how we connected power and torque together and we did the further calculations. Okay. Two solid shafts A and B are made of the same material. A shaft A is of 50 mm diameter and shaft B is of 100 mm diameter. The strength of the shaft B is, okay. As we had seen, the strength will depend on the polar section modulus. Okay. So two shafts A and 150 है यहाँ पे. So as we can see, the strength ZB जस्ट अ मिनट, ZB को हम लोग वी कैन राइट इट एज, सो पोलर सेक्शन मॉड्यूलस Z D क्यूब, ठीक है। सो देयरफॉर ZB अपॉन ZA इक्वल्स टू DB क्यूब अपॉन DA क्यूब, 2 क्यूब 8 times D. Always remember, when the strength is concerned, just consider the polar section modulus. So it's proportional to D cube. Keep in mind is that this is important point. Okay. So you will just, as you will solve the quickly as possible. A bar having length L and uniform cross section with area A is subjected to both tensile force and P and torque T. If G is the shear modulus and E is the Young's modulus, internal strain energy stored in the bar is simple. Na, I have not kept the option here because we will just write P square L upon 2 AE plus T square L upon 2 GZ. That's it, simple. Okay, just remember all this. And for the bending is M square L upon 2 EI. Okay, so this was pretty straightforward. 22nd. Consider a composite plate of steel and copper, okay, held between two rigid supports. If it is heated to a certain temperature, then okay, okay. Let's suppose this is copper, this is steel. Now we have to find which will be in the compression, which will be in the tension. Now see, I will explain you conceptually. If this support was not here, okay, so alpha of copper is naturally greater than alpha of steel, okay. The copper would have expanded, suppose still here. This was the initial, copper would have expanded till here, okay. And steel would have expanded up till here. But now the situation is, oh, I'm sorry, I must correct this question, okay. There is one correction in this question, everyone note. Not the support, there should be support. There is no any support here. Extremely sorry for this. They both itself acts like a support to each other. Sorry for this. Okay. Now at the end, when it is heated, it will come to an final temperature, final length somewhere here. Okay. See, the copper is was expanding till here, but it is now expanding till here. So this is compressed this much. And steel was just expanding till here, and now it is expanding till here. This is intention. So always remember the one with a higher alpha compression, okay, and lower alpha tension. Just remember this funda. You will never get it wrong. Okay. So this was also a good question. Okay. So we have reached up to 20 seconds. So let's see if there is another question. Okay, so let us now solve the question 23rd, the last question of this session. When a load of 20 kilonewton is gradually applied at a particular point in the beam, let us consider this is a cantilever. This is not mentioned over there. Consider a gradually applied load of 20 kilonewton. Okay. Maximum stress of 20 MPa. Okay. And a deflection 10 mm. What will be the height from which a load of 5 kilonewton? Okay. So W2 is equals to 5 kilonewton. Fine. Should fall into the beam at the same point if the maximum bending stress is, no, sigma max is 50, 40, sorry, 40 MPa. 40 MPa. Now for such kind of question cases, always remember one formula like sigma. This is the from dropping from height. Okay, so this is called as the not applied loading. This is called as the sudden impact load. Okay, so this is called as, just a minute, give it a second. Some problem here. Yeah, okay. Now see, this is impact loading. Okay, so delta impact is delta static into 1 plus root over 1 plus 2h upon delta static. Okay. Now if you see here, delta static in case 2 would be, see, load is becoming from 20 to 5. Okay, 20 kilonewton to 5 kilonewton. So deflection will go from 10 to 10 mm to, so I think this is 1 by 4 na. So this will go to the 2.5 mm. Okay, so this should be 2.5 here. And height we have to find sigma static. We know how much was 20, and we will consider, no, not 20. This is uh 5 kilonewton. I think I'm not wrong. This should be 5. Oh, sorry. Yes. Since loading becoming 1/4, so sigma will become uh 5 MPa. Okay. So 40 is equals to 5 in, sorry. I think I will just write it again. Just a minute. Sorry for the inconvenience. See, always remember the load is W1. Here the load is W2 should be equals to sigma 1 upon sigma 2 is equals to delta 1 upon delta 2. Okay. So 20 upon 5, this 1 by 4th, sorry, 4th, 1 by 4 time reduce hoga na. So sigma 2 would be also becoming, it is maximum. Just don't confuse with it. Maximum 40 MP it could take. So okay, it is producing 20. Now it will be producing 5 MP over here. Okay. And delta 2 would be equals to 2.5 mm. And there is one formula as I wrote earlier here also. Sigma impact, sorry, sigma impact is equals to sigma static 1 plus root over 1 plus 2h upon delta static. Just put these all values in this formula, you will get answer as the 60 mm. I think, I hope you this got this question. This was beautiful concept used here. Okay. So I hope you all got the all questions today we had discussed. If you have any doubt, if you have want to give any feedback, just WhatsApp me or in the WhatsApp group or the Telegram group. I am always available there, and our team is always available with you. Okay. So with this, I am ending this. Thank you.